Very religious reasons.
Okay, it seems better now.
My guy.
Okay, so I don't know. The quality of the previous video was not good for some reason, so I didn't upload that, and I don't have time to review everything, but I just want to recap a little bit what we learned yesterday. So trigonometry that we learned is only for the right angle triangles and for the acute angles till now. So this is the only thing that you will learn in Math 1C, not more, okay? So let me just remind you a little bit. So if I have a right angle triangle, a right angle triangle is a triangle so that one of the angles is 90 degrees. And let me call this one A and B and C. And then I have two acute angles. An acute angle is an angle which the size is between 0 and 90 degrees. Greater than 0, smaller than 90 degrees. I have two kinds of those angles in a right angle triangle. In this triangle, I have one of them is B, the other one is C. Okay? There are three numbers that we want to associate with every acute angle. Okay? One of them is called sine. The other is called cosine, and the other is called tangent. So as soon as I have an acute angle, for example, B, I can ask you what is sine of B, I can ask you what is cosine of B, I can ask you what is tangent of B. Yes? In principle, we should be able to answer these questions for this acute angle. I should be able to answer these questions for the other acute angle. Yes, I can ask you what is sine of C, what is cosine of C, and what is tangent of C, yes? Okay, so there was a definition for sine. So if you remember, what was that? I want you really to memorize things. These are important things. So sine was defined to be equal. This semicolon means defined to be equal. In a right angle triangle, I'm just emphasizing, whatever I'm telling you is only valid if I have an acute angle and if I have a right angle triangle, yes? So sine is defined to be the opposite sine, so let me write OPP for the opposite, divided by the hypotenuse, yes? And then what was the definition for cosine? Cosine was the adjacent one, if you remember, divided by the hypotenuse. And tangent was defined to be the opposite side divided by the adjacent side. Yes? So that is what we had before, for sure. So this is important to remember. Okay, for example here, what is sine of B? Sine of B, B is this angle. If I want to find sine B, I need to find the opposite side to that angle. And that's a convention that if I have a triangle with vertices called A, B, and C, the side, the length of the side opposite to capital A is denoted by lowercase letter a. This is a standard convention. And if this is capital B, the length here is denoted by lowercase letter b, and the same thing here. Yes, this is a standard. And then when I say sine of B, you need to go and look to the opposite side, which is B, and then divide it by the hypotenuse, which is A in this case. So this becomes B over A. And if I ask you about cosine of B, cosine is adjacent side divided by the hypotenuse. And I told you that might be this was confusing. Which one is the hypotenuse? The one which is opposite to the 90 degrees angle, 90 degree angle is called the hypotenuse in a right angle triangle, yes? So when I say cosine B, you need to find the adjacent side and divide it by the hypotenuse. So if this is your B, you see that this side and that side, both of them are adjacent to B. But when I say adjacent, I mean C, not A, because the name of A is actually hypotenuse, so it is not confused. So if I ask you what is cosine of B, you would say it is C divided by A. And if I ask you what is tangent of B, it is the opposite side divided by the adjacent side. So this is B, the opposite side is B, the adjacent side is C. So this becomes B over C. Yes? And we can do the same thing here. So I go here, and if I ask you sine C, you use the formula again, the definition. You say that this is the opposite side divided by the hypotenuse, so it is C over A. And if I ask you what is cosine of C, the adjacent side, which one is the adjacent? We have two of them. Of course, the name of this is the hypotenuse, so this would be the adjacent one, and then divided by the hypotenuse. And then if I ask you what is tangent of C, that is the opposite side divided by the adjacent side. So this becomes C over B. Yes? So these are the definitions that we had before. Okay, immediately we realize there is a nice simple pattern going on here. You see that B over A here is repeating itself. So B over A appears here and there. It appears here as sine of angle B. It appears here as cosine of angle C. And the same thing happens here. Yes, C over A appears here, and C over A also appears here. But here it appears as cosine of B, there appears as the sine of C. So then, do you remember what was the rule behind this? I told you that this is a very important remark. Let me write it here. So what is the conclusion? So what is the relation between B and C? B is this angle, C is this angle. Because this angle is 90 degrees, and because the sum of three angles should be 180, so what is left for these two is 90. Yes, so it's always B plus C is 90 degrees. And we see that if B and C are 90 degrees, if I add them, it becomes 90 degrees. Sine of B is equal to the cosine of C, and cosine of B is equal to the sine of C. Yes. So these two, the name of these two angles is called complement angles. So what is the complement angle? We say that alpha and beta, angle alpha and angle beta are called complement angles. If what happens? If when I add alpha and beta, the answer becomes 90 degrees. So remember this word, okay? So this word might have different meanings in English, but when it comes to angles, complement angles are the angles whose sum is equal to 90. For example, 15 degrees and 75 degrees is a pair of complement angles. Why? Because 15 plus 75 is 90. Yes? Okay, and the remark is this. So let me write the remark in a little bit different way from yesterday. So we say that if alpha and beta are complement, sorry, I should write complementary angles. Yes, complementary. If alpha and beta are complementary, so from this statement, you can, if you want to, you can conclude that sine of alpha is equal to cosine of beta, and sine of beta is equal to the cosine of alpha. I told you that this remark is very important, so please try to memorize that after understanding. Understanding is actually very simple. You see it on the board, so there is nothing very deep into it. But this is something that we will use it not only for Math 1C, for 2C and 3C and 4. Is that clear? So this we had before. And what is the relation between tangents of complement angles? We also see it on the board, yes? This is B over C, this is C over B. So they are reciprocal of each other, yes? So we can also conclude that tangent of alpha is 1 over tangent of beta. Yes, is that understandable when I write this? Because if this is 2/3, this is 3 over 2. So one of them is the reciprocal of the other one. But I myself prefer to write it in this way, or we can write tangent of alpha multiplied by tangent of beta is equal to 1. Of course, I am reviewing everything, but I don't want to go through very much details that we did last time. For example, we talked about this. If I ask you what is tangent of 15 degrees multiplied by tangent of 75 degrees, you don't need even the calculator to calculate this, yes? So, what is the answer? The answer is 1. Because 15 and 75 are complementary angles. So if I have two complementary angles, the product of the tangents of those angles is exactly equal to 1. So you really don't need to calculate this using the calculator. But if you just change 15, for example, to 16, then I will not be able to answer it. I have to use the calculator or a little bit more advanced mathematical methods, yes? Is that clear? So this is one relation I really want you to remember. Another relation which is very important to know is what is this combination? So sine squared, we calculated this before. So sine b to the power of 2 plus cosine b to the power of 2, we calculated this yesterday. Do you remember what the answer was?
1.
It was 1 again, yes? So why is that? Because this is b over a squared plus c over a squared, and then I can immediately write b squared over a squared plus c squared over a squared, and then because the denominators are the same, so I can write this, and then what comes to my help is the Pythagoras Theorem, yes? So I can write a squared divided by a squared. Why? Because this is a right angle triangle, and we know that b squared plus c squared is a squared. So for the numerator, I can write a squared, and the denominator is already a squared, so this becomes equal to 1. So it doesn't matter how much this angle is. What matters is that this angle is somewhere between 0 and 90 degrees. And by the way, let me emphasize again, these formulas are not correct if you want to use them for a. You are not allowed to use these formulas. They are not formulas, by the way. They are definitions. These definitions are not valid for the angle A. This only works for the acute angles, not angle A. Yes? Be careful about that. Yes?
Does that small hat on alpha and beta, does that just mean that they're complementary?
No. Hat means the angle. You usually, when you write sine alpha, you don't need to emphasize this hat. So I don't know, in Swedish books I have seen that people put out the angle sign here. And I don't know, in more standard books, they write it like that. And we can also write this. If I want to read this, I would write angle alpha, angle alpha, angle alpha.
Okay.
I am using this symbol for the notion of angle. But here I don't need to emphasize, because when I write sine of alpha, alpha is automatically an angle.
Okay.
Of course, if you write that hat here, that's not also that's also correct.
I might have just missed you explaining it, but the tangent of alpha is equal to 1 over tangent of beta, or tangent of alpha is times tangent of beta is equal to 1.
Yes?
Is only one of them true?
No. Or equivalently.
Okay.
Yes, that's a good
So
question.
both are true.
Yes, or equivalently. Thank you for asking. That's that's not very clear from what I wrote. Okay, so this is something that I want you to remember. So I would say that if theta is an acute angle, meaning that this angle between 0 and 90 degrees, then you need to remember that sine of that angle to the power of 2. Yesterday I told you that instead of writing this, even though this is the correct form of writing, but people write it as this. Yes? So whenever you see this symbol, it means this. Because By the way, I told you that yesterday. Yeah, let me repeat that. If I give you an angle, and if I ask you raise it to power 2, this is meaningless. Because an angle is a shape. Yes, is a geometric shape. And I cannot ask you to multiply a geometric shape by itself. So this is meaningless. Yes? But this is meaningful. For example. This is meaningful. So this is meaningless, but this is okay. Why this is okay? Because even though theta is an angle, what I get at the end for sine is a pure number. Why is that? Because, for example, sine is this number divided by that number, and they have the same dimensions, yes? This is a length, this is also a length. If you divide two lengthless, it becomes a pure number, yes? So even though theta is an angle, but sine theta is a number. And am I allowed to raise a number to power 2? Yes. And then, so this is the correct way of writing, but this is the standard way. People write like that. Even sometimes I read it wrong. I read it sine squared theta, but that is wrong. I should read it sine theta squared, yes? Because sine theta is a number, then I have to square it. So be careful about that. So now, using that convention of the way of writing, I would write sine squared, sine theta squared plus cosine theta squared is always equal to 1. Okay, so of course in the future we will see that this formula is always correct. So far the trigonometry that we are studying is limited to the acute angles, but later we will learn what is the meaning of a bigger angle. For example, even in trigonometry we can have 1000 degrees, we can have negative 2500 degrees. These things we will learn later. Yes, please?
Since sine squared is meaningless,
Yes?
why is it written like sine squared and then theta?
Yeah, I told you that. This is the way that the books use it. So it is meaningless, but if I tell you that this is the meaning, this is no longer meaningless. Yes?
Oh.
Yeah, that's it.
I thought.
Now, yeah, you are right, because sine squared theta doesn't have any meaning, yes? So, but I am telling you, whenever you see this, this means this. Yes?
Okay.
So instead of putting this pair of brackets, we write like that. So that's a convention. Whenever you see this, you need to interpret it yourself in this way. Yes, now it becomes meaningful. Yes, yeah, I have to be careful. Okay, so be careful about these things. So that's also a very important thing that I want you to know. So for example, if I ask you what is sine squared of 20, I usually read it wrong, sine 22.5 degrees squared plus cosine 22.5 degrees squared. Of course, if you ask me this combination, I really don't need my calculator. I see that 22.5 degrees is an acute angle, and this combination is very famous. You need to train your eyes to catch this pattern immediately in trigonometry, yes? So sine squared of an angle plus cosine squared of the same angle is equal to 1. Yes? So this is 1. I don't need to calculate anything because of that. But then tell me, do you remember we had some problem like this? So what is this number, sine squared of 15 degrees plus sine squared of 75 degrees? Yes, Sergey? Why is that?
Because sine in the sine of 75 are complementary,
Yes?
which means that sine 15 degrees would be the same as sine 15 degrees plus cosine of 75 degrees.
Yes, exactly. So what you are saying is that 15 degrees and 75 degrees are complementary. So instead of having sine 75, if I want to, I can take this away and write cosine 15 instead. Yes? This is the content of this remark. Yes? So So the answer would be sine squared, sine 15 squared plus, instead of sine 75, I write this, so it becomes cosine 15 squared. And then this becomes this exact combination. So the answer to this also becomes equal to 1. When I was checking your book, I saw this question, by the way. The book has written this. A is an acute angle. Do you think this is true or false? Something like this.
Yes.
So this is the way that the book has asked you to discuss about this. A is an acute angle. Do you believe that this equality is true or false, or it depends to the value of A?
True. True.
It's always true. Why? Because A and 90 minus A are complementary angles. Do you agree? I don't know A, I don't know 90 minus A, but I know something. I know that if I add these angles, what would be the answer?
90.
This minus A and A cancel, it becomes 90. So this and this are complementary angles. And we learned that if I have complementary angles, sine of one of them is equal to the cosine of the other one, yes? So this is the way that your book has asked the content of that remark. So what more? So I told you that this remark is very important. This is a very, very famous formula. I want you to memorize that. It is not hard. And then there is another formula. Do you remember? We discovered that in the very last minutes. What was that? Yes?
Sine of B divided by cosine of B is tangent of B?
Yes. So tangent is not independent from sine and cosine. If you have sine and cosine, you divide sine by cosine, it becomes tangent. And why is that? For example, we can consider one of these things. For example, let me just change my color and write it here. For example, let us consider about B. I divide sine B by cosine B. Yes. On the right hand side, I have B over A, I have C over A, so I divide them. Is this logical or not? Because sine of B is equal to that, cosine of B is equal to this. It is clear that if I divide these two, it becomes equal if I divide these two. But then, this A and that A are cancelled, and what is left for you is B over C. But now look, what is another name for B over C is tangent of B, yes? So this becomes tangent of B. So now if you look here and here, you got a formula. You got the relation between sine, cosine, and tangent. So tangent of an acute angle is the sine of that angle divided by its cosine. Yes, so that's also very important. So let me clean this. We don't need this anymore. But let me just write it here for you. So here, I would say the same thing. I would say that if theta is between 0 degrees and 90 degrees, then tangent of theta is equal to the sine of theta divided by cosine of theta. I want you to really remember these two combinations. This is not hard at all. You need to train your memory as well. Of course, later we will learn that these two formulas are always valid. You don't need to limit yourself for this interval. That's always valid. Yes?
So if we have a number for sine and we have a number for cosine, we can always determine the number of tangent.
Yes, immediately. Yes.
Is it possible to go the other way around? If we have
Yes. But that is a little bit more complicated. But in principle, you need one of them. That's a good question, by the way, Sergey is asking. Let us discuss a little bit about that. If I give you sine of an angle only, can you find its cosine?
Yes.
Yes, which using this formula. If I give you sine, you put it here, the unknown is cosine, you find it, and then you divide them, it becomes tangent. So if I just give you sine, it is enough to determine tangent. Yes? If I give you cosine, you put it in this formula, you find sine, and then you divide them. So even if I give you cosine, it is easily seen that you can find tangent. Yes? But the question that you ask about tangent is a little bit more tricky. If I give you tangent, you should be able to find sine and cosine out of it. Yes, that's a good question to think. Yes, it was very clear. For example, by the way, let me ask you a question. Do you think this is wrong? If I tell you that theta is an acute angle, so that sine theta is 2, you immediately need to criticize about this. So I'm asking you a question. Assume that theta is an acute angle, so that sine of theta is 2. You need to immediately press the alarm and say, Bobak, this is not possible. Why? Yes?
Because the answer cannot be higher than 1.
Why?
Because
Yes, you are right. The answer cannot be larger than 1. But why? Even it cannot be equal to 1 in the case of right angle triangle. No one else? Yes?
Because the opposite side can't be longer than the hypotenuse.
Yes. That is actually true. So remember, of course, this needs a proof. It needs a proof, but unfortunately in the book they are not discussing about these things. The people who are working in Mathematics Olympiad, we will talk about geometry in a very solid way later, okay? But anyway, here, remember that in any triangle, the side opposite to the bigger angle is larger, is longer. So I hope that you agree with me that this 90-degree angle is greater than this angle. It's also greater than this angle. So the side opposite to it, which is the hypotenuse, is larger than this one and that one. Yes? Because the angle opposite to it is bigger. So, and then you have a fraction here. You are dividing b by a. So the numerator is b, the denominator is a. Which one is greater than the other one? The denominator. And if the denominator is greater, it cannot be a number greater than 1. And it cannot be equal to 1. Of course, later, yes, if you take your calculator and ask what is sine of 90 degrees, the calculator will give you exactly 1. But this cannot be seen from here. Okay, so don't use that formula that I'm using for that one. That's a different story. But for the time being, this is wrong. Yes, this cannot happen. So everyone understands? So what about cosine, by the way? If I write cosine theta is 2, do you agree with that?
No.
The same reason, no. But what do you think about tangent, by the way? If I write tangent theta is 1000, do you criticize that immediately? Yes?
No, because tangent is just made up of a fraction of B and C.
Yes?
Yeah.
Okay,
Yeah,
but
of any combination of B and C in a fraction.
okay, can you motivate me just intuitively?
And then we can make this fraction be arbitrarily large by making B or C arbitrarily large with
No, by making the numerator arbitrarily large, or fixing the denominator, or making the denominator small as well.
Yes, which geometrically would be stretching the triangle.
Yeah, exactly. So let me just describe that what Rasmus said. This is good to understand. So you see, if I write sine theta equals to 2, you should criticize me. If I write cosine theta is equal to, I don't know, square root of 3, do you criticize me or not?
Yes.
Yes, because the square root of 3 is still larger than 1, so you criticize me. But if I write tangent of theta, if I write 1000, that's possible. You cannot immediately criticize me, because why is that? What Rasmus said is completely okay. So what we say, for example, let me consider this. My goal is to show that tangent can be arbitrarily large. Why? Because here, let me stretch this triangle. So here, tangent B is this side divided by that side. Let me keep this side the same, but let me increase this side a little bit.
It's not true.
Okay? And then complete this triangle. Of course, this angle is now larger. The tangent of this new angle and the tangent of the old angle, which one is bigger? Yes, it's clear the new angle. Yes, why? Because the tangent of this new angle is the opposite side from here to here, for example. Let me call it B number 1. So this becomes B number 1 divided by the adjacent one, C. And the previous angle was B over C. Which fraction is bigger? This fraction and this fraction have the same denominators. The numerator is longer. So this fraction is bigger than that fraction. So this means that the tangent of this new angle is bigger than the tangent of the old angle. Yes? But I can stretch it even more. Yes? I can make this a little bit longer. I can go to sky. Yes? And then this becomes a bit. So by the way, this angle becomes closer and closer to which number?
90.
Becomes very close to 90, but it does not become 90 if I want to do that. Okay, it means that tangents, there are no upper bounds for tangents. Yes? But there are upper bounds for sine and cosine. They cannot exceed 1. But tangent can be any number that you like. Yes? Okay, so that's important. But then the question becomes a little bit tricky. If I give you sine, if I give you cosine, you can find the other way around. You can find the other one and then divide them, you can find tangent. But that's also a good question to think. What happens if I give you tangent and I ask you to find sine and cosine? Yeah, this is not in the book, so let us just ignore these things because there are many things that we have to cover. But think about this, brother. Okay, but one more thing. Do you think that I can write this? Do you think this is true or false? Of course, that's the same story. What is the meaning of tangent theta squared? In principle, this means what? Okay? But if I want to write quickly and I write this equality, do you agree that this equality is true or not? Is it true or not? Why?
Because both sides are responsible for 2.
Yes, we are raising both sides to power 2, yes? So if you want to see this, we can say it like this. I can say tangent to the power of 2 theta is a short way of writing this. Yes? But what is sine theta? What is tangent theta? It is sine theta divided by cosine theta. And then I want to raise it to power 2. But then we learned in the very few sessions in the beginning that if I have a fraction and I want to raise it to power 2, I will have to take the numerator to power 2 and the denominator to power 2. But then there is a short way of writing this. What is that? This is sine theta and I put the power of 2 here, and for the cosine the same thing, yes? So now you see that if you do not do these intermediate steps, it is immediately clear that these two are the same. So from now on, whenever we need, we use it without proving it, yes? So I can just write this one as a remark here. So what I can do, I can write tangent not only to power 2, to any power that you like. Let me call it k. Theta is equal to sine theta to power k divided by cosine theta to power k. So that's also good to know. Okay. What else we talked about? Do you remember yesterday? Yes?
The angles 30, 45, and 60.
So these are, I told you, remember the names. These are famous trigonometric angles, yes? And can you answer this question? Do you remember why they are famous?
Because we can determine
we can determine the exact values of sine, cosine, and tangent of those angles with very little geometry, not very advanced geometry, yes?
Very small geometry.
So I don't want to go through that lesson. We did it yesterday, but let me just rewrite the table here for you, yes? So the table we completed, you will always get this table if you need for solving a problem. So you don't need to memorize that unless you need to remember these famous angles.
In this case, it's
Yes? So then, by the way, let me just write this one for
all
you.
the angles. They will actually sides are the same.
So for 30 degrees, if you go back, it was 1/2. And then cosine theta was the square root of 3 over 2. And this one was 1 over square root of 3. But we gave it two different names. Some books use this name for that. Some books use this name. Yes? But now, giving you this column, I don't expect you to memorize them. It of course doesn't hurt if you memorize. But if I give you this, you should be able to write these numbers immediately. What are those numbers? Because 30 and 60 are complementary angles, so you immediately be able to write this. Sine of 30 is 1/2, so it means cosine of 60 is 1/2. And then cosine of 30 is this number, so this sine of 60 is the square root of 3 over 2. And what is the tangent of 60 according to this? It should be reciprocal. Reciprocal of this is easier to imagine. Yes, a square root of 3 goes up, 1 goes down. But 1 goes down, we don't need it. So the answer is what? This. Okay, and then if you remember, we calculated these two. So it becomes 1 over square root of 2, which is another way you can write it in that way. And this one also the same. Okay, now if I give you these two pieces of information, you immediately can calculate this. How? Because tangent is sine divided by cosine. Yes? So it becomes this number divided by itself, which becomes 1. So that's also something that I want you to remember, especially the names. I don't expect you to know the details here, but I really expect you to know that these angles are famous in trigonometry. Another important thing that we covered yesterday is that if I ask you, by the way, there was a nice geometry property for this angle. I want you to also, the people who actually are interested in solving harder problems, to remember this. If you have a right angle triangle, yes, and this angle is 30, if this is x, yes, this becomes 2x. Remember this picture in your head. Yes? It's good to remember this fact. If I have this 30 and this is 90, the side opposite to it is half of the hypotenuse. Yes? And that is one, we proved this, and after that we were able to find sine theta to be equal to 1 over 2. Sine 30 degrees 1 over 2. Okay, another question was, if I ask you to, for example, if I ask you to calculate, if I give you a ruler and a protractor, and I ask you to measure, not calculate, measure, for example, sine of 15 degrees. Okay, I give you a ruler, a fairly precise ruler and a very precise protractor. And I ask you to measure sine of 15 degrees. What we are supposed to do? Yes?
We can draw a small triangle with one side 15 and the other side 90 degrees.
Not side, angle.
Angle.
Yes?
And then we can measure the side.
So what you are saying is that I draw a line. I use my protractor to make a 15 degrees angle, yes? 15 degree angle. And then I choose one point on this horizontal line. It doesn't matter. So this is my question. I choose one point and then I draw a perpendicular line to make my right angle triangle ready. Okay? And then I take my ruler. Sine is opposite side, so I take my ruler and I measure this distance. For example, I get number x. And then I take my ruler and measure this distance. For example, I get y. And then what I do, I divide x by y. Yes? Of course, this might not be exact value because the precision of my ruler and protractor is limited, but it is a roughly good approximation for that. Yes? But there is one very important question here. So you saw that I made the angle 15 degrees, but I said that I choose a random point here. Could I make this point closer to this or more or farther away from this? Of course, I will have different triangles, yes? If I had chosen this point instead of that point, then I do the same thing. And then I will take my ruler and I measure this one. This is no longer the same x. For example, let me call it x1. And then I will take my ruler and measure this one. Of course, this is no longer the same y. So let me call it y1. And then, so might be I do it with the blue triangle, you do it with this green triangle. You get this. You get this one. Which one is correct? Yes?
Both are correct.
We learned that both of them are correct, and if it was not the case, we will be in trouble, yes, because it depends how do you draw the triangle. But there is a theorem that guarantees that even though x is different from x1, even though y is different from y1, but this x over y is exactly the same as x1 over y1. Yes? This is the reason is that we will learn later in Math 2C that this triangle is similar to the other triangle. We will talk about that later, but you need to trust me on that. These two values are exactly the same. You will see this later. Okay, that's also something we learned. Okay, so if you don't mind, let me just do some of the problems in the book for you, and then put. There is one more part of the lesson left. I want to teach that one, and then you can start working on the problems yourself. First of all, I don't know, the people who have calculators, there are two units for measuring angles in any calculator. One of them is called degree. The other call is radian. I want you to make sure in the future in the exam that your calculator is set up in this mode. And how you check it, you calculate using your calculator tangent of 45. If you get 1, it means that your calculator is in the correct mode, is in the degree mode. If you punch tangent of 45 in your calculator, you get a different number, so then it means that you are in the radian mode. So you need to learn how to switch back to the degree mode. This is different from calculator to calculator. That is what you need to learn yourself. So because we calculated here, you see, tangent of 45 degrees is 1. So this radian, we will learn it in Math 4. So everything that we do in trigonometry in Math 1C is always in degree. So be careful if accidentally you switch your calculator to the radian mode, or it by default is in the radian mode, you will get all the numbers wrong in the exam. Be careful. So you have to make sure that tangent of 45 returns you back 1. If it returns you back 1, it means that you are in the right mode. We are in the correct mode. Okay. So, for example, I don't know, there are some very simple questions in the book. I don't know, should we solve it or not? Okay, let me just do one of them. So this is problem 3071. Okay, it's very, very simple. Determine sine of V, cosine of V, and tangent of V in this following triangle. So it's very, very simple. It doesn't hurt if you solve simple problems, yes? So this is 12. This is given to be 9. This is given to be 15. Okay, so let me change the problem a little bit at least, yes? So I will give you the same numbers, but if you don't mind, let me draw the triangle upside down. I want you to expand your visualization, yes? So this time I will take this 190. So that is essentially the same problem. I changed the way that I draw the figure. So I put 15 here. Everything is in centimeters, for example. And then this one is 9. And this angle is given to be V, or nu. Actually, I don't know which one they mean. This is the Greek letter nu. Yes? And then this is also 12. Okay? The only thing that I have done is I have just actually converted this figure in the book into this figure because I wanted to expand your point of view. Okay, so here, if I ask you what is sine of V or nu, can we calculate this?
Yes.
So what should I do? Remember the formulas. You can repeat and memorize. What was sine?
The opposite divided.
The opposite divided by the hypotenuse. But which one is the hypotenuse?
15.
The one which is opposite to this. So this is your hypotenuse and the opposite one is this one. So the answer is 9 over 15. And I want you to just simplify it, but do not put it in decimal form unless I ask you to do it. So you divide by 3, it becomes 3 over 5. In this case, this is exactly 0.6. Okay, this is also a good motivation here. You might ask, okay, what is important for me? I want to find the angle. This gives me the sine of angle is 3 over 5. How can I find the angle itself? That would be the topic of the next lesson. But for the time being, I just want to motivate you that in the future, in the short future, we will answer this question. What is V? But now let me ask you, what is cosine of V? Cosine of V is the adjacent side. Which one is adjacent to V? 12, not 15. 15 has a name. It is hypotenuse. And then if you divide by 3, it becomes 4 over 5. And if I ask you what is tangent of V is the opposite side, which is 9, divided by the adjacent side, which is 12. And you simplify it by 3, it becomes 3 over 3. So this is a very, very simple task to do. Yeah, the questions are very simple. I don't want to stick to those very simple questions. Okay, now let me use this motivation to answer this one. This is not at the level of your lesson. The only thing that you need to do is just using your calculator. Okay? If it happens that sine of nu is 1 over 2, you don't need your calculator. Everything is on this table, yes? So I want you to not only remember these numbers are famous, these angles are famous, I want you to remember these numbers are also famous in trigonometry. Yes? Because when I give you this question, you don't need even a calculator if you have this table. So what is V in this question? I'm asking for an angle so that when I take sine, it becomes 1/2. But I have 1/2 in front of sine for which angle? 30. So the answer is 30. But for this one, is this a famous number in trigonometry? 3 over 5? No, I don't have it in the table. Then what I'm supposed to do, there is only one way for you, for everyone actually, is to use the calculator. But of course, the calculator follows a mathematical algorithm. That algorithm is developed by mathematicians, but that is an advanced mathematics. How the calculator knows what to do is a different story. But at the level of your lesson, you need to learn how to use the buttons on the calculator to calculate V. Because this number is no longer one of these famous numbers here. Okay, so what I'm supposed to do, there is a button on the calculator. You see something like this. And for cosine, you have something like this. and for tangent you have something like this. And that is unfortunate symbol. I will tell you why, but this is what it is. You have to get used to it. This is called sine inverse. Read it in this way. Sine inverse. And this is called cosine inverse. And even the word is a little bit problematic. Tangent inverse. Okay, this is a real unfortunate symbol. I will tell you why. But for the time being, if I ask you to find V, from here, what you do, you write V is equal to sine inverse, and then put this number in your calculator. Yes? If you ask me, I don't know. I have to use, for example, the calculator to answer that question. But be careful. There are two types of questions. I can ask you find sine, cosine, and tangent. I can give you information and ask you find the angle, the size of the angle. Yes? If I ask you find the size of the angle, you need to remember there is a button on the calculator called sine inverse. You have to use that. So if sine V is 3/5 and I want to find V, I write V. You have to write this if that's a question that you need to show your answers. You need to write V is equal to sine inverse of 3/5, and then take your calculator. I don't know if the iPhone calculator is capable of doing that. I don't think so, unfortunately. I don't see any sine inverse here.
0.64.
Okay, so what is that?
64.
0.64. By the way, in the exam, I will ask you to keep how many decimal points? Okay, what is the next decimal point?
That's the only decimal points.
Okay, so in GeoGebra?
Yeah, in GeoGebra.
Okay, in GeoGebra you can adjust that to 2, 3, or etc. Probably it is only by default on 2, okay? So I will tell you, when you have the calculator, I ask you, calculate V. So this is not correct, by the way. This is not correct. Do you know why? Because GeoGebra by default is in radian mode. Okay, so this is extreme. I realize suddenly this angle is very, very small now. Because when you say 0.64, it is even smaller than 1 degree. Yes? So this is not correct. And this, I told you, this is a serious problem. If you don't adjust it in the degree mode, then it will be problematic. GeoGebra by default is, are you using the CAS view?
Yeah.
The CAS view is by default on, oops. So I don't know, I haven't checked how should I switch to the degree mode, but what is the answer that you have? Using the calculator. Yes, 36.869, so let me write 87 degrees. This is more sensible, and this is not equality, this is approximately equal to that. So be careful, this is good that we saw that. It was the wrong answer by GeoGebra, because GeoGebra by default gives the answers in the radian mode. Of course, if you know how to switch between radian and degree, then you get this answer again. But that's a different story. So if I ask you what is this angle, you would say that this angle is roughly 36.8 or something, yes? Okay, now let us check, might be the calculator. Do you think I can calculate V from this? In principle, the answer should be the same. Yes, let us check. So if I want to use this to calculate V, the only difference is that I have to punch this in my calculator. Okay, can you, Tim, calculate this one again?
Yeah, it's the same.
The same number. So you see there is no discrepancy. So it doesn't matter if you use sine of V to calculate V, or if you use cosine V, so you will get exactly this one. And if you want to use tangent, so can you do that one for me as well to double check everything? Is it the same number? Hopefully?
Yes.
Yes. So 36.87. So you see, if you know tangent, you use this button on the calculator. If you know cosine, you use this button. If you know sine, you use this button. Yes? Is that clear? But that is a little bit of mystery, yes? If you really want to, how the calculator knows how to calculate this. This is a different and hard problem. Not hard problem, but not at the level of the mathematics that we are studying right now. But for the time being, don't worry. You need to know how to use the calculator to calculate these angles. Yes, please.
So what is the inverse of sine? What is
Okay. That's a very good question. So why this is unfortunate? The reason is that if I ask you what is another name for this symbol, x to the power of -1, what is that one?
1 over x?
It's 1 over x. Okay? So it is x to the power of -1 is 1 over x. And I just told you, for example, what is the meaning of sine squared theta? This means sine theta to the power of 2, yes? Now, automatically, we think that this should also be the case for this one, yes? Yes? If you are thinking in that way, you need to be careful. This is not the interpretation. Because if you interpret it in that way, then you can write 1 over sine theta. Okay? This is why I'm saying it's unfortunate. Yes? Because usually in mathematics, we shouldn't be so careless about using the symbols and notations. The reason that the mathematicians have used this, because they talk about the inverse functions, which is a different story. This is the reason that they use it. But in some books, because this is a little bit problematic, they do not use this symbol. Instead of sine inverse, they write arc sine. Instead of cosine inverse, they write arc cosine. And instead of that one, they write arc tangent. Then it's a good notation, I would say, because there is no matter of confusion. But the problem is that it is a little bit longer. Might be it's not easy to fit it on the button of a calculator. I don't know. So, but be careful. In the book, we are not using arc sine, arc cosine, arc tangent. But if you see it in some other books, that's not a strange. That's exactly the same thing. Yes.
So are you trying to replace using arc instead of -1 for arc sine?
Yes. Instead of writing sine inverse, of course, I'm just telling you that in some way this is also true. If you think of this as a power, who knows, yes? Because assume that someone has written this on the board and has left the classroom, and the next teacher comes in. When I see this, I really can have two interpretations. If I don't see that you are talking about the sine inverse, I might interpret this as a power, which is a valid way of interpretation. Or if I understand that you are talking about sine inverse, I will say, this is why I prefer myself to use this symbol. There is no matter of confusion there. But that is inevitable, the book is using, and the calculator, you don't see this button on the calculator. You always see these buttons on the calculator. Okay? But if you see arc sine, arc cosine, arc tangent in other books, remember, that's not a strange thing, that's exactly the same thing. Is that understandable? Yes or no? Okay. So, this is something that I want you to know, but let me now ask you some question. So, do you remember we were talking about the motivating question that we entered the trigonometry was that finding the height of that flagpole, yes? So let me just go back here. So we have a flagpole here. I want to ask one question here. I am looking here, so I'm standing here. And this is very high, so I cannot measure it. I cannot measure the height very easily. What I do you remember? I can take the meter tape and measure this distance. This is easy. For example, I measure this and it becomes 10 meters. For example. And then, do you remember we had an instrument yesterday? What was the name?
Clinometer.
Clinometer, yes. The pronunciation was not, the accent was not that. What was that?
Clinometer.
Inclinometer?
Clinometer.
Yes?
Clinometer.
What?
Clinometer. Or
Yes, clinometer, yes. Or anything like that. Okay, what is that? You can take it and just point it to the topmost point on the flagpole, and then using that instrument you can read this angle. Okay? For example, let us assume that we got 36 degrees, for example. And now I want to find this height. So how should I do? I can measure the distance from my eyes to the ground level. So let me just do that. For example, let us make it 165 centimeters or 165 meters, 1.65 meters. Okay, and then I want to find this height. So what should I do? By the way, do you remember what was the name of this angle? These names I want you to learn.
The angle of elevation.
Angle of elevation. Remember, this angle is called the angle of elevation. If the angle of elevation is the angle between the horizontal and your line of sight, if that one is higher than your eyes, if that point is higher than your eyes. If that point is lower than your eyes, that is not called the angle of elevation. That's called the angle of depression. Yes? Okay. So, angle of elevation. And now I want to calculate h. So what can I do? I can say that, so you see, this is important for you to learn. For this one, I have three options: sine, cosine, and tangent. I have seen students try all of them, but it takes time. You don't need to try all of them to see which one works. Which one is suitable for this case? Sine, cosine, or tangent, and why?
Tangent.
Why tangent is suitable?
Because we know this.
So, what I want to know is opposite.
Yes.
What I have is the adjacent. Do you understand? So I do not have any information about the hypotenuse right now. What I have is something what I need is something opposite to the angle. What I have is the adjacent one. So I don't need to think about sine and cosine. Which one I choose? I will choose the tangent. Yes? And what I would write tangent of 36 degrees is equal to this. How much is this one? From here to here is capital H, which I don't know. But this becomes capital H minus 1.65. Yes? So this becomes H minus 1.65 divided by 10. Yes? And then what is my unknown in this equation? Is this unknown? No, this is just a fancy way of writing a number. It's a number which is known. This is known, this is known, H is not known. And then it means that I should be able to find H. I have to make H alone. Yes? So what is the first step to do to make H alone? Multiply by 10 to get rid of fraction. So it becomes 10. And I would really recommend you do not be in a hurry to put this in the calculator. Do some algebra. It will increase your skills. So this becomes 10 tangent of 36 is equal to H minus 1.65. Yes? And then move this to the other side because your goal is to make H alone. So it becomes what? 10 multiplied by tangent of 36 degrees plus 1.65 is equal to capital H. By the way, this is completely okay for me. If I ask you what is the exact value of the height of the pole, this is the answer. You just leave it like this. Yes? But usually for engineering problems, this is useless because you want to have a sense of, you want, for example, to order this. So you cannot go and say that, okay, I want a flagpole of this size. You need to give a more tangible number, yes, to a practitioner. So then you take this, and I recommend you to punch everything in one go in the calculator or GeoGebra. Because if you just take this one, of course this problem is not hard, but if you want to use this number for something else, you are accumulating the errors on top of each other. Because if you put this number, for example, something like that, you get 2 decimal places, you have some errors, and if you take that number h, and if you want to use that h for another part of the problem, you make another error there, so your errors are actually getting bigger and bigger. So this is why I really highly recommend you to solve this algebraically, and then put all the thing in GeoGebra or calculator and get the answer. Yes? So what is the answer then? Can you do that for me? 2 or 3 of you can do that. Let us check the answer. So what's the answer here? Yes?
8.91.
8.91.
So
So if that is correct, what is the unit? Is meters. Can you check, someone else, can you check this, double check for me?
No, it's on side sheet.
Okay. So what, okay,
It was 5.
okay. So, yeah, I don't know, this is a different convention. Some people say that write 8.9. Okay, anyway, that is your answer. Okay? But now, yes?
how does GeoGebra know what the tangent of
What?
the tangent of 36?
I told you, I don't know. You just take, for example, GeoGebra. By the way, in GeoGebra, you have access to this. If you go to the typing keyboard, it is written f of x. If you push on this one, click on this one, you will see this symbol. So if you want to use GeoGebra to calculate this, just write this and then put this symbol. Yes? But what was your question exactly?
Well, how can we solve that ourselves? The tangent of 36 without...
No.
It's not
Of course, when the calculator knows how to do, it means humans also know how to do it. But the mathematics that tell you how to calculate is beyond what you need, what you have right now. Okay? So for the time being, you only use the calculator. But of course, when GeoGebra knows how to do it, it means that someone has programmed it in that way. Yes? Okay. I want to give you one motivating question. This was easy, but now assume that you want to find the height of a mountain. What would be the problem? What would be the main difference between finding the height of a mountain and height of a flagpole? Yes, let me clean, and I want everyone thinks, and I come back to you. So the question is this. Of course, mountain, I don't mean Mount Everest, yes? So assume that we have a hill, not so big, because we have problems with our sights, especially if you are old now, like me. So let us have a hill. If we want to find the height of the hill using trigonometry, okay, what I have is just a meter tape, and then I have that clinometer. Yes? But what is the main difference for this question and this question? Yes, Buol, I think you raised the hand first.
You can measure the length to like the highest point.
Yeah, exactly. So what I have, so assume that this is your hill. Yes? And then you are standing here. Of course, you have the meter tape and everything you want. You have that clinometer. So the point is that here, I have to measure this one up to here, yes? But this point is the point that makes the right angle here for me. In that case, where is it? In that case, it is not accessible to me. I want to find this height. Yes? So, it is useless to measure this from here to here. Because that is not a right angle triangle. I have to have a right angle triangle. And that one is not accessible to me. So then, what is your suggestion? Should we give up or we can find another way? Still, I have a meter tape in my hand and I have clinometer. Yes?
Is the top of the hill accessible to you?
Accessible means climbing there?
Yes.
No.
Okay.
I think a pair of legs would be a good start.
What?
Perfect.
Difference having the legs.
Yeah, that's the thing.
Okay.
Okay. You have no legs, that's why you can't climb.
Yeah. Good.
Do we need anything more than the angle elevation
Device point.
to actually solve it?
No, I want you to think about it.
I don't think we need anything more than the angle of
So the instruments that you have, the apparatus is just a meter tape, for example, 5 meter tape, and then you have a clinometer. And of course, you have a sharp sight and things. Forget about the minor errors that you might make in adjusting it or something like that. But you are right, by the way, Tim. If you mean that this tip might be, this should be in your sight. Otherwise, there's no. So you should be able to see the top in some way, okay? But now you want to solve that problem. Yes?
Are you allowed to measure the distance from like you to the top of the mountain?
No.
Oh, okay.
Not allowed, but assume that you really want to do that. It's not practical, yes? And even if you can climb, measuring this distance practically is hard. You want to just send the tape or do what do you want to do, yes? It's not that easy. Yes?
You can use a similar triangle since you have the angles.
Which angles? Just tell me everything. Assume that you are the engineer and you want to really measure and give a number to the company. So what do you do?
Oh no. I hate combined.
Yeah. You need to be careful. When you want to be paying salary, you have to do your job well, yes?
Man får ju ändå lön.
Yes, Rasmus?
Pretty sure I've seen this problem, but I can't remember exactly how it did. But I think they started by measuring the angle at two points,
Yes.
and measuring the distance in between
Yes.
the 2 points.
Yes. So you said that you have seen this picture somehow. You are right. That is the trick. This is the simplest trick. So what that person do or does, for the time being, I don't know, we don't need to think about this. We can just think about here. Yes, that's not a problem, yes, because otherwise I need to add this constant to that, yes? So you don't worry about it. So, we take the clinometer and read this angle. This is doable. Let me call this angle alpha. Alpha by itself is not enough. Yes, because tangent of alpha is the height, okay, that is good. This is something that I need. Clinometer provided this angle to me, so there is no problem here. But tangent of alpha is this distance divided by that distance. This is not accessible. But as Rasmus said, that person can walk a little bit forward and measure the angle again. Okay, so what we do, so let me change the color. So I can move a little bit forward and I can measure this distance. I don't have any problems with measuring this distance that I am walking forward, yes? And then measure the angle of elevation once more. Yes? So this becomes that. So let me call this angle beta. So you see, what I am doing is possible. Yes, I have a meter stick, I have a meter tape, and I have clinometer. I measure this one, I move forward, for example, say, I walk L meters to the right, I get closer and measure the angle once more. So if I ask you what numbers are in my hand now, I would tell you that alpha you know it, beta you know it, and L you know it. Now the thing is that if you are a good mathematician, these numbers are enough for you to determine H. We want to discover how. Okay? So if you want concrete examples, might be it's good for you. For example, assume that the first one you get 15 degrees, for example. And after walking 10 meters forward, you measured this angle and it turns out to be 20 degrees. For example, now I am asking you, if you have these three pieces of information, try to use mathematics to find H. Yes, I will pause the video recording and I want to give you time, because if you can solve this problem, you don't have any problems with trigonometry at this level. If you can solve this problem, everything is okay. There are some good problems, 2-star problems in the book. I really want you to see them, okay? But please think about this problem first. Yeah, please listen to me. I want you to have a strategy. I told you several times, if you want to be a good problem solver, randomly doing things is not very, very useful in mathematics, yes? Might be coincidentally, by random doing things you get an answer, but the probability is not that high. You need to have a strategy. So before start calculating, you should plan a strategy for solving the problem. Might be the strategy is wrong. You start doing that, following the strategy, you see that there is a dead end for that, then you have to go back again, you have to have a strategy to continue. Yes, I know this is tempting, people start using, even sometimes myself, if the problem is hard I cannot solve, I do a lot of random things sometimes. But then I will go back and say, okay, Babak, this is enough, you need to have a strategy. Yes, so what is your strategy here? You need to think in this way, so that you can cook up a strategy and then follow it. Sometimes it fails, sometimes you succeed. If you succeed, you are done. If you fail, you have to go back, but don't do it again randomly. You have to design, you have to devise another plan to carry on. So, how do you think about this problem? Yes?
What I thought is like, since it goes up by 5 degrees after 10 years, you could technically just keep going 10, like, you could, like, for every 10 meters it goes up 5 degrees.
Is it clear? Why do you take this for granted? When you are talking about that, this is not granted in my head, unless you prove it for me. I don't see, because here this happened, you say that next 10 meters this will happen again. This is intuitive way. It's not mathematics. This is not bad. This intuitive way might give rise to a good plan. But you need to convince everyone that this is indeed the case. Yes? Which I don't believe that this is indeed the case in this, unless you can prove it. Yes? And then one more thing. You don't know the next 10 meters you are in the hill or still outside the hill.
Yeah.
Yes? That's another deficiency with that plan. Any plan? Yes.
What if we draw this, but which smaller with a smaller scale, in a smaller scale?
What do you mean by the smallest case?
So you know the 10 meters we can draw it on the paper as 10 centimeters.
Yes.
Instead.
Yes.
So if we
That's also in the paper, by the way.
yeah.
So someone has done the measurement. You yourself has done the measurement. You got alpha, beta, and 10. Okay, and then you are doing it in your office.
Yes.
Yes. So it's on the paper now.
Yes, you can draw
It's not 10 meters, by the way.
Yeah.
It's just 10 centimeters around. It's 10 meters is longer. So that's also a shorter scale. No, but a strategy of solving the problem. Yes, Rasmus? But just give me your strategy, I will do it.
I thought that if we imagine that the line from or the base of the line that is adjacent to beta, so like angle that's
So let me, by the way, let me give them names so that you are more comfortable. Let me call this one A, let me call this one B, let me call this one C,
yeah.
and let me call this one D.
Yeah, so the line from B to C.
Yes?
I call that L2.
Okay.
And then we can say that a tangent of 15 degrees is equal to h over L2 plus 10.
Yes?
And then we can also say that the tangent of 20 degrees is equal to h over L2.
Yes. Yes, that's correct.
And then
Yeah, that's correct. Yeah. So if you want to solve this problem, first of all, let me ask your understanding a little bit about the problem. If you want to have a good chance solving this problem, and this is the topic of trigonometry, and we know that sine, cosine, and tangent can in principle be involved. Which one do you have the higher chance to be used here to solve this problem? Sine, cosine, or tangent?
Tangent.
Why is that? Why do you have this feeling? Yes, tangent is correct. If I want to solve this problem, I don't know, but the first thing that I want to try, I will not think about sine and cosine in this problem, at least at the first attempt. Yes, in the first attempt, I will choose tangent. Why?
Because I want to know.
I want to know the opposite.
And
Of course, sine is also related to the opposite, but sine is related to opposite and hypotenuse. Hypotenuse is this one or that one. I do not have any information regarding them. Yes. So if I want to have a chance to solve this problem using the lesson that we learned, forget about sine and cosine, just stick to tangent. So this is a strategic thinking, yes? So I don't care about sine and cosine in this problem. I will care about tangent. Okay, now we have a little bit of plan now. I want to think about tangent. Okay, what is tangent of alpha? Can I say something about tangent of 15 degrees in this picture? I need to consider this bigger triangle, yes? Because 15 is the angle of this bigger triangle. So what can I write? What can I write? It is the opposite side divided by, can you tell me, divided by? From A to?
Adjacent.
Adjacent, which is from A to C. Yes? Agree?
Yes.
This is something that I have. So which one is not known? In this equation, I have three parts. Tangent of 15 is no problem for me. I have my calculator, I can calculate it. H is the unknown for me. I am looking for this guy. But the point is that I have another unknown. Yes? AC is not known yet. Yes?
Don't you have to write AC with line drawing?
In principle, in Swedish book they use it like this. Yeah, in the British book they have to use something like this. Not line on it. Line on it means...
Maybe that's the German way. I went to German school before and we always wrote it as AC with a line.
Yeah, but I agree that you need to put something there because AC is the line segment and then you can use them interchangeably because when I am dividing, this cannot be a line segment, then it represents the length. So you see, I have two unknowns involved here. Okay, let me calculate tangent of 20 degrees. What is your opinion about tangent of 20 degrees? Can you tell me? What is tangent of 20 degrees? I have to go to the smaller triangle and write what?
H
over BC. Yes? This is the strategy I want you to learn. Okay? So, if I ask you how many relations you see, I have two relations, two pieces of information. But how many unknowns are involved yet? How many unknowns are involved? Is this unknown?
No.
No. Is this unknown?
No.
How many unknowns are involved? This is the strategic thinking, yes? How many unknowns? What? 3. One of them is H, we don't know. One of them is AC, I don't know. One of them is BC, I don't know. Yes? So how many unknowns I have? I have 3. How many equations I have? 2. It is not enough. If you want to find 3 unknowns, you need 3 pieces of information. Okay? So you have only 2 unknowns. Sorry, 3 unknowns, 2. So I need another piece of information. And this is why there is another piece of information that I haven't used yet, which is these 10 meters. Yes? So how can I use that piece of information now? Can you tell me? So that it is related to these unknowns. So what can I do? Yes?
The tangent of 20 degrees is H over B minus 10, A minus 10.
So what, can you tell me another piece of, forget about algebra, what is another piece of information that I can write which is related to this?
BC is 10 less than AC.
Yes, so BC is equal to AC minus 10. Is that understandable?
Yes.
So now let us look at the problem again. These are very important things, by the way. So now how many equations you see? Three. How many unknowns you see? Again, 3. So that's enough. In principle, if you know what to do, you are relieved at this point because you are solving 3 equations with 3 unknowns. This is the way that you have to think. And then, do I need all the unknowns to find? No. The only unknown that I care is h. So I need to focus my energy, instead of finding all these things, I just focus my energy to find the unknown that I need, that is h. Yes? Okay, then this becomes algebra. You see, up to here is planning the strategy. From here, after that, it's just algebra. Okay, now, of course, algebra is also important. Might be you can write them, but you cannot solve them. But you need to practice on that one as well. So what can I do now? What can I do here? I will start, for example, from here. I want you to tell me that, do you understand here? If I write AC is equal to h over tangent of 15, do you agree with me or not?
Yes.
Yes? So this means that AC is equal to h divided by that. So from here I can conclude that BC is what? H divided by tangent of 20. And I take this one and put it in this equation. Then I have the only unknown left for me, and that is h. So instead of BC, for example, I write h over tangent of 20 equals to, instead of AC, I write h over tangent of 15. Yes? And then minus 10. Yes? So this is one equation, but how many unknowns are involved here? One. And that is exactly the one that I need. So in principle, I am done. Yes, I should be able to find that. Okay, now let us go back to the previous lesson. How do you solve this? The problem is that now your strategy is complete. You succeeded to find a good equation, but the problem is practical problem. You have to solve it and find h. How should I solve this?
Get rid of
Denominators, yes? Do you think there is not, I want you to broaden your points of view. Is there any main difference between this equation and this equation? The people who see this complicated, so I have this experience. You need to teach yourself right now. If I give you this in the exam, can you solve it or not?
Yes.
How do you do that?
Least common denominator.
You multiply by 12. This problem is exactly the same problem. But instead of having number, very simple number 4, I have this seemingly a little bit more complicated fancy number. But that's a number, yes.
Sorry, what was it? Minus 1?
Oh, sorry, minus 10. Sorry. Thank you very much.
But
Yes?
are their relation the same as 4 and 3? Tangent of 2?
No, I don't know. But I'm saying that the structure of this equation and the structure of this equation are the same. In principle, if you can solve this problem and you cannot solve that problem, you need to teach that yourself because they have the same structure. Yes? So can you tell me what should I do now? If I want to solve this, you told me that multiply by 12 to get rid of the fractions. What should I multiply here? I want to get rid of this fraction, I want to get rid of that fraction simultaneously. So what should I do?
Find the least common denominator.
So what is the least common denominator here?
It's 60.
No, we don't know. Tangent of this multiplied by tangent of that. That's the only thing that I can do. Yes? So what I do, I take tangent 20, tangent of 15. These are numbers. Don't freak out about these things. These are just numbers. You multiply everything by that and that. Yes? Yes? Agree? And now what happens? This tangent of 20, whatever it is, and whatever it is, they're gone.
Yes.
And then this becomes tangent of 15 multiplied by h. Yes? And what happens here? If I multiply this inside, tangent of 15 and 15 are gone, this is left. times h minus this expression multiplied by 10. So don't get disturbed by the length of the calculation. Yes? Is that understandable? Okay, then what is the next step? If you want to solve this equation, this is an equation in one unknown. You need to make that unknown alone on the left hand side. So what is the motivation? I will take this one to the left. Tangent of 15 h minus tangent of 20 h is equal to 10 minus 10 tangent of 20 tangent of 15. Yes?
Yes.
And now what is the next step? Can you tell me? Let me write it on top here. So can you tell me, my goal, don't forget, h is your unknown, don't lose your strategy. Your strategy is to make h alone. So what should I do? Yes?
Divide both sides with tangent of 20 times tangent of 15.
No, I want to make h alone.
Divide them.
No, before division we need something. So let me ask you, if I write 5x minus 2x is equal to 10, how do you solve this?
Simplify them.
So what do you write?
3x.
3x equals to 10, and then x 10 over 3. This problem is the same problem. But here, you did it in your head. How did it in your head that you got 3? You wrote in your head 5 minus 2 times x.
This is in this case.
That is the same. I just want to tell you that when you answered me 3x, in your head you subtracted 2 from 5, and then multiplied by x.
So
Here the numbers are so simple, we could do this. Here the numbers are a little bit different, so we should do the same thing.
Tangent of 15 minus tangent of 20.
Exactly. So you see, this is the way that I want you to learn. So to think in this way. So this becomes tangent of 15 degrees minus tangent of 20 degrees times h equals to that number. Minus 10 tangent of 15 tangent of 20. Yes? And then I want to make h alone. So what should I do? I have to divide by this number, whatever it is. Yes? I divide that, it becomes what? Minus 10 tangent of 15 tangent of 20 divided by this number. Tangent of 15 minus tangent of 20. And then you write meters in front. This is the exact answer that you find it. Yes? But this number might not be very useful if you want to do some practical things. So you need to put this in the calculator. And this is one of those cases I really want you to be able to do the algebra first. I have seen students put tangent of 15 right in the beginning. That's no problem, of course, but you make some error when you write tangent of 15, because tangent of 15 has infinitely decimal places. When you just cut it at some point, you make some error here, you make some error here, and then you multiply them, you are making those errors, and then you divide by them, so you are making the error bigger and bigger. So this is the point of algebra. Do everything algebraically and then simplify it in one go. Type this in GeoGebra in your calculator and execute. That would be the best answer that you will get. Yes? So you see that what is involved in this problem is, you see, 15 degrees, 20 degrees, and 10. All those pieces of information is necessary to be able to solve that problem. Okay? And then, by the way, do you think this number becomes negative?
What?
Because I have a negative sign here. And if it is negative, I have real problems. Because it means that it is under the ground.
Tangent of 15 degrees is
less than. Thank you. There is no problem. Yes? Tangent of 15 degrees is less than tangent of 20 degrees. So the denominator is also negative. The numerator is also negative. When you divide them, it becomes positive. These are also double checks that you need to learn. If it was the other way around, I have to learn that I have done something wrong. These are important things that if you want to be a good mathematics problem solver, you need to be able to do these things. Okay, I don't know, if you have time, you can put this in the calculator and give me the answer. Otherwise, the lesson is finished. What's the answer? 10 point
15668.
15. So let me write 67 meters. I don't know. This we need. You need to check yourself. Everyone, please check it. By the way, this is some skill that you need to learn, either using GeoGebra or your calculator. Yes. So you need to learn how to put this directly in the calculator.
Or we're gonna have the calculator on our next exam.
Yeah, if it is necessary, I will give you access to the calculator.
Damn, boy.
So we're gonna
Okay.
or we're potentially gonna have to do this on the next exam. Or is that big answer?
I myself usually prefer exact answers because I am properly mathematician, not engineer. For me, exact answers are a little bit sacred, you know.
Also,
That's up to you. Thank you very much.